All right, we have three equations and three unknowns. And the very first thing we would like to do is write this in a matrix so then we can get this form, because this will allow us, well, if we say each one of these columns are our variables, if I get z equals whatever the value of z is, then I can back substitute z to solve for y, and back substitute z and y to solve for x. So the first part's fairly straightforward. You just simply write the coefficients. Remember, if there's not a number, there really is, that's 1x. So 1, 1, do not lose your negative signs. Negative 3, 4, negative 1, 1, 3, negative 1, 4, negative 3, and 1. All right, now the order matters. The order matters. Step 1, turn the very first upper left-hand corner into a 1. Did it. It's already a 1. All right. Step 2, turn this value into a 0. All right. Now, I can manipulate this row, because if you remember in algebra, as long as you do the same thing to every term, you're just doing a multiple of the row. And in this case, I can actually add rows. So if you think about it, if I want that to be a 0, why not take the negative 4 times row 1 and then add it to row 2. And you have to understand why. If I take negative 4 times 1, I get negative 4. I add it to 4, I get 0. I could care less right now about these other numbers. All I'm trying to do is turn that 4 into a 0. Anytime you want to turn a number into a 0, you're going to use another row. All right, not changing row 1, so I'm going to just copy these values back. I'm not changing row 3, so I'm just going to copy these values back. All right, I am going to change row 2. And being this is the first example, let's actually write this out what I'm doing. So I'm taking negative 4. So in this row, every one of these values, I'm going to multiply by negative 4. So negative 4 times 1, negative 4, plus what's already in row 2, which is 4. I'm going to take, so that's the first one. I'm going to take negative 4 times 1 again, which is negative 4, and then add it to negative 1, or minus 1. I'm going to take negative 4 times positive, or negative 4 times negative 1, which will be a positive 4, and add to the 1 that's already in there. And then finally, negative 4 times negative 3, which will be a positive 12, and add it to that 3 that's already in there. All right, so over here, just copy down, once again, row 1, didn't make any changes there. Copy down, once again, row 3, didn't make any changes there. Now do my calculations. Negative 4 plus 4, that was the whole reason I did this. Don't care about these other numbers, but I'm going to do the calculations. Minus 4 minus 1, negative 5. 4 plus 1, positive 5. 12 plus 3, positive 15. All right, we're ready to go to our next one. The next thing we want to do is turn this negative 1, or I guess I should be over here, this negative 1 into a 0. Well, look at row 1. What if I just simply take row 1 and add it to row 3? Because I can already see 1 plus negative 1 is going to give me 0. So let's write down, I'm not changing row 1. I'm not changing row 2. I am going to change row 3 by taking row 1 plus row 3. There's my 0. Once again, could care less about these other values, but I need to do the calculations. So 1 plus 4, 5, negative 1 plus negative 3, negative 4, and then negative 3 plus 1, negative 2. All right, doing good. So far, so good. All right, the next one I would like to change is turn the negative 5 into a 1. And these are actually easier to do because anytime you want to turn something into a 1, you just simply multiply that row by its inverse. All right, so notice the inverse of negative 5 would be negative 1 over 5. So technically what you're doing, you're dividing each one of these values by negative 5. All right, didn't change row 1. Didn't change row 3. And now I'm going to take and I'm going to divide every term in row 2 by negative 5. Well, 0 divided by anything is 0. I didn't want to change that, so now you can kind of see how this order matters. Negative 5 divided by negative 5, positive 1. 5 divided by negative 5, negative 1. And then 15 over negative 5, negative 3. All right, we're getting closer. Next, want to turn this 5 into a 0. Remember I said when you want to turn things into zeros that you are going to need another row. And you might say, well, could I use row 1? Well, no, because then when you add, you're going to mess up that 0. So use row 2 because you'll still end up with a 0. So take negative 5 times row 2. Why negative 5? Because I want this to be opposite of 5. And then add it to row 3. All right, not changing row 1. 1, negative 1, oops, negative 3. Not changing row 2. 0, 1, negative 1, negative 3. But I am going to change row 3. So I'm going to take negative 5 times 0, which is 0, plus 0, which is, I didn't want to change that. Negative 5 times 1 plus 5, the whole reason for doing that. Then negative 5 times negative 1, positive 5 minus 4. So nicely, this step already gives me my 1. Doesn't always work that way, but nice it did. Then negative 5 times negative 3, positive 15 minus 2, I get 13. All right, so remember these columns are x, y, z. So I can see z equals 13. Back substitute 1y minus z equals negative 3. Well, z is 13. And then if I add 13 to both sides, I get y equals 10. And then finally, x plus y minus z equals negative 3. So x plus 10 minus 13 equals negative 3. Well, that's going to give me negative 3. I add it to both sides, and I'm going to get x equals 0. That's a 0, not a 6. So the solution set then for my 3 variables will be 0, 10, and 13. So it's kind of like a little game that you're playing here. You just want to get your starting matrix to look like your ending matrix.